Hello Year 6 and welcome to this flipped classroom on fractions. During this session, we'll look at what a fraction is, how to create an equivalent fraction, including simplifying, and also how to convert between a mixed number and an improper fraction back to mixed number. So let's start with what a fraction actually is. It's a mathematical way of describing part of a whole. Simple as that. So here's our whole. We've got this rectangle here, and we're going to divide it into 4 equal pieces. Now we can divide it into as many pieces as we like, as long as each separate piece is equal in size to the others. If they're not equal, then we're not dealing with fractions, okay? So fractions must be equal pieces. In this particular case, we've got 4 equal pieces, which means our denominator, the bottom number in our fraction, is a 4. And if we decide to shade one part of it, then our numerator, the top number, becomes a 1. 1 over 4, 1 out of 4, 1 quarter. Different ways of saying exactly the same thing. So we've got a quarter here. A quarter of this shape is shaded. 1 out of 4 is shaded. Now we could look on the flip side of that and count how many are not shaded. Well, 3 of them are not shaded. Out of 4, 3 out of 4, 3 quarters not shaded. Okay, so that's how we build a fraction. We find out how many equal pieces there are altogether, and then how many we're particularly interested in. Maybe it's shaded, maybe it's how many have been taken, or so on. Let's take a look at these. We've got the same square, but it's been split into a different number of equal pieces. So the first question I'd like to ask you is, how many equal sections has it been cut into? Well, in this first one, it's been cut into 2. This one's 4. This one's been cut into 8 equal pieces. And finally, 16. Now, these numbers are going to become our denominators. These are how many equal pieces the shape has been split into. The next question we ask ourselves is, how many sections are blue? This first one, 1 is blue. This one, 2. This one, 4 are blue, and this one is 8. We use these 2 digits to create our fraction. Okay, so what fraction is blue? 1/2. 1 out of 2 is shaded. The next one, 2 out of 4, 2 quarters. The next one, 4 out of 8, 4 eighths. And the final one, 8 out of 16, or 8/16 are shaded. Are these fractions equal? Are they equivalent to each other? Well, by looking at the diagrams, we can clearly see that the same amount of the original square is shaded blue. So if you ignore the thin black lines, you can see that the same amount of blue shading has been completed on all 4 shapes. So yes, they are equal, they are equivalent. How could we do that mathematically? How can we make 1/2 become 2 quarters, become 4 eighths, become 8/16? Well, by multiplying. And in this first case, we're going to multiply by 2. To create an equivalent fraction, you multiply top and bottom by the same value. So 1 times 2 is 2, 2 times 2 is 4. For this one, 2 times 2 is 4, and 4 times 2 is 8. And finally, 4 times 2 is 8, 8 times 2 is 16. Because we've multiplied top and bottom by the same amount, we have created an equivalent fraction. A couple more examples. Here's our square. This time it has been divided into 3 equal parts, 9 equal parts, and 36 equal parts. How many bits are shaded? 1, 3, and 12. What's that as a fraction? 1 out of 3, or 1/3, 3 out of 9, 3/9, 12 out of 36, or 12/36. And are they equal? Yes, we can clearly see from the diagram that the same amount of the square has been shaded. And how could we do that mathematically? Well, we can multiply. We can multiply the 1/3 by 3. 1 times 3 is 3. 3 times 3 is 9. So 1/3 is equivalent to 3/9. What about getting from 3/9 to 12/36? Well, this time we're going to multiply top and bottom by 4. 3 times 4 is 12. 9 times 4 is 36. Okay, so 3/9 is equivalent to 12/36. So, to sum up, to find an equivalent fraction, you multiply the numerator and the denominator, top and bottom, by the same number. Little challenge for you. Here's an example to find 3 equivalent fractions of 2/5. The first one, I've multiplied top and bottom by 2 to give me 4/10. That is an equivalent fraction. On this one, I've multiplied by 6. 2 times 6 is 12. 5 times 6 is 30. So 12/30 is an equivalent fraction. And finally, I've multiplied by 24. 2 times 24 is 48. 5 times 24 is 120. So 48/120 is an equivalent fraction. You can multiply by any number you like, any whole number that you like. So here's a few examples or a few practice questions. If you'd like to pause the video and have a go at these, you are more than welcome. I'm looking for 3 equivalent fractions to each of these. Remember, you multiply the top and the bottom number by the same amount. Okay, have a go at those, but I'm going to carry on with our learning for today. Now, to simplify a fraction, it's the same as creating an equivalent. We are creating an equivalent fraction, but this time the digits within the fraction are smaller. So instead of multiplying the numerator and the denominator by the same number, we're going to divide it to make the values, to make the digits within the fraction smaller. And we're going to keep dividing until we can't divide anymore. Here's an example. We've got 12/30. So to make them smaller, we're going to look for a number that is in both 12 and 30. So what numbers, what are the factors of 12 and 30? Well, let's try 3. 3 goes into 12, 3 goes into 30. So we'll divide top and bottom by 3. 12 divided by 3 is 4. 30 divided by 3 is 10. 4/10 is an equivalent fraction, and it is smaller. It is a more simplified pair of numbers. Let's see if we can go further. Is there a number that goes into 4 and goes into 10 without leaving a remainder? 2 does. 4 divided by 2 is 2. 10 divided by 2 is 5. 2/5 is a simplified version of 12/30. They are equivalent, but this is simplified. The digits are smaller. Okay. Remember, you can only divide by a common factor, a number that goes into top and bottom without leaving a remainder. Once again, here's a few practice questions for you to have a go at. Can you simplify each of these 12 questions? Pause the video, have a go. I'm going to move on. So, to wrap up equivalence, whatever you do to the bottom, you do to the top. If you multiply or divide both digits in a fraction by the same number, you will always get an equivalent fraction. Just be careful when dividing that the number goes into both the numerator and the denominator. We can't have fractions in fractions. Okay. Right. What you're looking at there, 7/6, is what we call an improper fraction. Improper fractions are where the numerator, the top number, is larger than the denominator. Now, we've drawn it out here. What we've got is our original shape, our original rectangle is split into 6 equal parts. That creates our denominator. Remember, denominator is simply how many equal parts the shape is split into. So we've got a whole rectangle there, and we've got another whole rectangle here, split into the same equal parts, where only one of them is shaded. So altogether, we've got 1, 2, 3, 4, 5, 6, 7 parts shaded. Okay, so 7/6. It's more than the whole one. Another example, our squares here have been split into 4 equal parts. That gives us our denominator. But as well as the 4 that are shaded here, we've got another one on a second shape that's shaded. So you can see we've got more than a whole one. And as an improper fraction, we would say 5/4, 5/4. Now in this example, Our original rectangle has been split into 6 equal parts. Okay, so our denominator we know is going to be 6. And altogether, 9 of them have been shaded. So as an improper fraction, we're looking at 9 over 6. But we're also looking at one whole one here. The whole of that rectangle is shaded. So we've got a whole one and 1, 2, 3 out of 6, 1 and 3, 6. Okay, so 1 and 3, 6 is the same as 9 over 6. So one whole one and 3, 6 is the mixed number. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 6 is our improper fraction. But they are the same amount. They are equivalent. So we can change between mixed numbers and improper fractions, like 1 and 3, 6, and 9, 6, using a little bit of maths. And we're going to look at those two processes now. Here we have a mixed number. Now, a mixed number is a whole number with a fraction, 1 and 3, 6. Now, this is showing us that our shape was split into 6 equal pieces. That's our denominator. Now, that doesn't change because with our improper fraction, the denominator is still 6. We've still split it into 6 equal pieces, but we want to know what our improper numerator is going to be. It's going to be bigger than 6 because it's an improper fraction, but what's it going to be? The way we do it is a quick multiplication. We multiply our whole number by our denominator. So we do 6 times 1, which is 6. We then add on the extra. We add on the numerator. So we take our 6 and we add the 3 to it, giving us 9. 1 and 3, 6 is equal to 9 over 6. So 6 times 1 and then add the 3. Let's have a look at another one. 2 and 1/3. We know the shape has been split into 3 equal parts. So that value, the denominator, stays the same. Okay, it doesn't change. So there's our 3 as our denominator. But what's our numerator going to be? Whole number multiplied by denominator. 2 times 3 is 6. We then add the numerator. So 6 plus the 1 gives us 7. 2 and 1/3 is the same as, it's equivalent to 7 over 3. What about turning the other way? What about improper fractions to mixed numbers? Well, here we've got 16 over 5. Now, it's over 5. Our shape has been split into 5 equal pieces. So our answer, our mixed number, will have 5 as its denominator. That doesn't change. The bottom numbers will always stay the same. Now, what we're asking ourselves here is actually 16 divided by 5. So let's ask ourselves that question. What is 16 divided by 5? Well, it's 3, remainder 1. Now we're going to use this answer to create our mixed number. The 3 becomes our whole number, and the remainder becomes our numerator. Okay, so 16 divided by 5 is 3. That's our whole number. Remainder 1. Okay, that becomes our numerator. And if we go back to the previous slide where we're turning mixed numbers into improper fractions, we can do our check by saying 3 times 5 is 15 plus 1 is 16. Oh, look, that's what our improper fraction is. So it works both ways. Another one, 17 over 3 is how many thirds? Our 3's remain the same, both sides of the question. Doesn't matter if it's improper or mixed, the denominator stays the same. So we ask ourselves, what is 17 divided by 3? Well, 17 divided by 3 is 5, remainder 2. Our 5 becomes our whole number. Our remainder 2 becomes our numerator. Okay. And once again, we can check it going the other way. 5 times 3 is 15, plus the 2 is 17. And that's the number in the original question. So that works as well. You can watch this video or bits of this video as often as you like. Practice, 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 guys. Hope it all made sense, but feel free to ask in class at any time if anything is unclear. We will see you next week. We'll see you in class. Take care.